Okay, welcome everyone to Module 6, Governance Design in our Web3 games. And again, the name of this lecture is Governance Design in Web3 games, or just Web2 games, games in general. We will focus on Web3, and the main part that we're going to be discussing is how we can empower our players with decision making and the ability to, add input to the games that they're playing. So an overview of why governance matters in our Web3 games. We're going to look at player ownership versus the developer control and different types of governance systems that we can add. So what is governance in games? A few points that we have here is the process of making collective decisions. So a group of people can act on a proposal for adding a new level, or maybe there's like a broken character in a fighting game and there needs to be some rebalancing, things like that. It often involves token weighted or role-based voting. So it could be like you have a bunch of tokens and you can throw it at a particular vote, like so, one token, one vote type of thing. Or it can be based on roles. So a certain level of player has a specific role, and the players with these specific roles can act on specific types of governance proposals. So governance can affect the content, balance, treasury, or policy. You come up with something that the wider community you want input from and allow them to use their voice with, tokens or roles to, vote on these particular types of proposals. So what are the benefits of in-game governance? It really like brings the community on board. They will trust your project. They'll be loyal to the project, and we don't really have to explain too many reasons why. If you have an engaged community, they're going to stay a lot longer and have more input into the future of the project. It reduces a centralized risk from the dev team or the core team itself making all the decisions for how the game progresses in the future. It gives players stake, of course, in the game development, especially if you have like a lot of Web3 games are open and in the public. They're iterating and designing and developing their games. And as this kind of progresses, if you have your engaged community, playtesting beta in the game, they're going to be throwing out, ideas. And some of these ideas are actually really, really good. But it might be hard to change this with inside of the core team itself. Now, if you add this layer of governance on top of this, those decisions are going to be made from the actual community, which has in the future, they're the ones that are going to be keeping this game alive. And of course, the engagement on this last point here is paramount. The more that your community is engaged and feels like they are a part of the development process or a part of the game and the decisions that are made in the game, then they're going to definitely stick around a lot longer. Some of the risks, so with everything, there's always going to be risks and there's going to be, downsides to it. So here we have some of the points of poorly designed governance in our Web3 games. Voider apathy, right? They like somebody or they have some kind of affiliation with something, and their vote is based on that and not for the good of the project. Whale dominance. So if you are writing a smart contract and you don't have whale protection, then you can have one player with a large amount of tokens, and then they can basically obfuscate the vote, not for the betterment of the overall project, but for their individual gain. There's definitely different attack vectors via the proposals. So this comes into the original, actually the first two, where you can have a core part of the community that wants to vote for a specific thing because it benefits that group of players or some component of the game. Or you could have a whale who can basically buy votes from other people and they kind of join this whale in their direction. This can delay in decision making or development because even though you have this on-chain voting governance, people sometimes feel that they got cheated or that the process wasn't fair. So we want to basically balance that, but nothing's perfect. So this last point here, really hard to master, but if you have watched the previous lecture where we mitigate and do a lot of this balancing and simulation, we can kind of maybe find some of these things ahead of time. So governance models, direct voting, one token equals one vote, delegated voting, vote via trusted representatives. So this really takes into account I have a game and there's a new proposal for adding in a new level, or maybe there's a payout for the top players of the week or something like that. Let's just take that as an example. And I am staking my tokens. So in this system of governance, in order to vote, you must have the tokens, and I am holding these tokens. Now, there usually is with every gaming community, there's going to be someone who has, a good reputation within the community. And I, as a player, respect this person and I have my tokens staked, but I don't want to be involved with every round, but I want to be involved with governance. Maybe there's some rewards, maybe there's some other incentives for doing so. And I'm going to hand off my responsibility for voting on specific proposals to this specific type of person. Quadratic voting, this is a lot more complicated. I'm not really going to get too deep into it. It does limit whale control, and by the amount of tokens that you're putting in, not one person's large bag will be greater than the sum of a bunch of other people that have, say, single amount of tokens, but the same amount of tokens as a whale. So let's take into account that you have one person that voted on a proposal, they have 10,000 of these tokens. And then you have 10,000 people that all voted with one token. Well, in retrospect, this would be an even vote, right? There's 10,000 by this whale and 10,000 votes from these individuals. Now, in a quadratic voting system, the 10,000 individual voters is greater than the whale who just voted with 10,000 tokens. So we have off-chain, which is basically just taking a snapshot of some on-chain activity or some activity governed by whatever it may be. Or you have on-chain, which is done via, smart contracts and, direct inputs from an EOA or an externally owned account. So let's look at some of the in-game use cases. So voting on balance changes or patches, there's an update to the game. You ask the community, hey, this is what we're doing. Do you guys agree or disagree? Electing community council members, right? So there's, as we talked about before, where you have these representatives that might be in charge of voting for specific proposals that come up. And there is a community vote in order to elect these representatives. Proposing funding for new game features. So say the game has a treasury. This is very common in Web3 games. And you want to take some of those funds in order to maybe do some marketing, it may be for adding new features, hiring new people, things of that nature. And of course, managing treasury and reward pool. Say you want to give out some free tokens to the community, or some of these elected council members, maybe they are paid from the treasury and these get voted on, maybe every 3 to 6 months, or, you can kind of pick a timeline. I'm just using examples. So let's look at an example in a decentralized guild governance. So players in a guild vote on raids, rules, and resource sharing. Okay. The guild NFT holders get special powers and DAO-like structure with on-chain incentives. So these are kind of some things, and there's a lot more, but we can use our imagination as some of these items that would be directly integrated inside the game in order to handle specific governance issues. So best practice for game governance is we want to start with simple governance mechanisms and get something in as early as possible. Now, this may be just for voting if we should have a governance model, but start off small, start off with something that's easily consumable, and start with something that is easy for the community to be involved in, right? Add in an incentive for voting is a great way to get your community to start engaging in this process. Making voting fun and rewarding, as we kind of alluded to when we were defining the first point, is that you want it to be fun. Maybe there's like a part inside the game where there's like a town hall, and you, as a player, need to physically go, into the game to where the voting booth is, cast your vote, or like make it as engaging. And if you can, if your game allows for these types of things, allow for rewards. Protect against spam proposal attacks. So allowing, multiple people with multiple different accounts in order to, spam the voting process, or proposing proposal attacks in general. Allow these things to be very transparent and efficient. They should have the ability to be very transparent in the way that the voting is done, how the votes are calculated, how they're displayed to the end users, and make it efficient, right? Like if you're doing a Web3 game, use smart contracts. If you're doing a Web2 game, use some kind of decentralized compute. But as these votes come in, you're tallying them. Maybe there's like a dashboard that shows all this as well. So what is coming up next? In Module 7, we're going to look at the psychology of value in our games, and we're going to explore how emotion, scarcity, and ownership affect player behavior. And that's all for this particular video, and I'll see you guys in the next one.